Hey everyone, so this is the part 3 of reading through issue number 50 from Jeremy Daly's Offline Non newsletter. What we're going to do is we're going to jump into some articles, we're going to read a bit, and then we'll talk through it. Alright, so in the past ones we've gone through potentially like 15 articles. Now we're moving on to the next one here, which is how to schedule any task with AWS Lambda. So assumingly just from the surface, this is going to talk about potentially CloudWatch, working with Lambda as a trigger. Looks like we have some level of scroll bar over here, so we'll get into all that. In the meantime, I'll pause it and I'll see you in just a second. All right, so I just briefly read through it. So what Renato here is talking about is the different ways that you can use scheduling with AWS Lambda and Serverless. And what he mentions here is that this is a really powerful aspect of Serverless in general and working with Lambda, is the fact that you can do this event-driven approach, which he believes is the most powerful aspect of AWS Lambda. And so what ends up happening here is that there's a few high-level concepts here. There's a Dynamodb TTL, which stands for time to live table. And there's also S3 object expiration. And finally, a CloudWatch rule schedule. And so just jumping back up to the top here, the Dynamodb DB TTL table, what that's going to allow you to do is it's going to set an attribute on each record which can expire, and then when it expires it'll actually trigger a Lambda function, and that Lambda function will then read to see what the event was. And so you can actually set a DynamoDB table to trigger, and when it triggers that Lambda function it'll pass like a value called create, update, or delete. And then inside of that Lambda function you can then filter, do like if else branching, and you can say if it's a delete, then delete the record, or sorry, do some action, for instance. All right, sorry about that. My throat, as in the last video, as I was recovering from being sick, it looks like I'm still working through that at the moment. But basically, getting back to this, so you create a DynamoDB table, you set a stream up, which is basically just meaning that as records are coming in, it's then streaming that event to a Lambda function. And then down here, you can actually see some code where we're using Python here. We're importing the Boto3 library. We're importing DynamoDB and the DynamoDB table reference. And then we're saying put item into the database. We're giving it an item here, which is going to have our record. So you can see here we've got a couple of properties. We have customer ID, we have task. Remember, DynamoDB also takes JSON, so we're passing in a JSON object here. And then finally, we're passing in an expiration time. Expiration time is the main attribute here, and this is something that's being talked about down here. So the expiration time attribute, DynamoDB will compare that against the current timestamp, and it says when the item is overdue, DynamoDB will delete it. And so in this case, we're sticking a record into this database, which then is going to expire. And this is really nice because there's a lot of different use cases where you can think about, okay, well, if I want to trigger something, if I want this to be like a temporary storage, which is going to expire, and then when that expiration happens and trigger some event, DynamoDB tables with the TTL feature is like very easy to implement. And one note here says the frequency with which Dynamo will scan your items and delete expired ones may vary up to 48 hours. This is relevant because if your use case requires precise time, the implementation above is not recommended. So that's a really good note there. If you're doing any processing where it doesn't really matter if it's a 48-hour delayed, then this is a great use case for it, and it's very simple to set up. However, if it's not, then take the recommendation here and use potentially one of the other options that we have here. For S3 object expiration, he's saying that S3 is like Lambda for object storage, can reliably be used for text, images, videos, general asset storage. And he's saying that using S3 as a task scheduler for Lambda is very similar to DynamoDB streams. And so S3 has the same concept where you can actually have event triggers. And so when something happens, when an event happens on the S3 bucket, whether you're uploading something or deleting it, it can actually trigger a Lambda function. It'll pass the event and actually pass a reference to the S3 bucket where that file is, and that then allows you to do some extra processing. So here's a snippet here. It looks like he's importing Boto3 and JSON and datetime, and then he has his data object here, which is going to be passed into the S3 SDK command, or Boto3 command. So we have the customer ID, we have the task. There's no expiration time attribute similar to DynamoDB on this one. So that's a big difference there. But then on the S3 put object, you can see that he puts an expires attribute, and then he's passing a datetime there. And so he's giving it the key, the bucket, and then also this stringified JSON data. So the expires attribute is the main one to consider here. That's what's handling this triggering of when on delete. So when it says when the object actually gets deleted, S3 will invoke your function, providing the bucket name and the object key. With this information, your Lambda can retrieve the object contents from S3, read the task instructions, and perform the logic we want. Important. So as in DynamoDB, AWS does not guarantee an object will get deleted right after expiration, making this implementation unsuitable for use cases that require precise time resolution. CloudWatch rule schedule. So CloudWatch is a very typical one that people use. I know that we use it a lot at Serverless Guru, and we use DynamoDB TTL tables as well, and of course S3 when it's needed. But for CloudWatch, it's very easy because with the serverless framework, it's like 4 lines of code, and you can hook up a Lambda function to a timer, and you can say every 5 minutes, like execute this task, and that's really nice. Or every hour, every day. So CloudWatch is perhaps the most obvious choice for Lambda task scheduling. It's very simple to set up. There are 2 main disadvantages to this. One, only supports recurrent schedules. So for instance, every 2 hours, every 5 minutes, as we talked about. It's not possible to schedule a specific date for the event to happen. So for instance, if we wanted like May 31st of 2021, we couldn't specify that. There's no customized events, so each and every invocation of the Lambda by CloudWatch rule schedule will provide the exact same request payload. We cannot customize how Lambda will run based on only what the scheduler provides. And what's interesting about that is that but actually what's interesting is that with the serverless framework, you can actually you can create the event, and then you can actually pass it the payload, and then you can actually pass a dynamic value there. So for instance, I think one thing that we've done before was like we passed a dynamic URL into the event, or sorry, into the payload. And so then I want to say that each individual case we were passing a different URL, but that was done through the serverless framework and the serverless.yaml file. It may still end up being hard-coded slightly, but with that helping automation and not having to do it manually, it can be somewhat dynamic, I guess, but yeah. Okay. So he says that one challenge of using this sort of architecture is keeping control and visibility over what is going on in your system. Autonomous invocations can be difficult to track, especially when the application starts scaling up. In case you would like to stay on top of your stack while still reaping the benefits, recommend Dashbird. So shout out to Dashbird Disclosure. He's a developer advocate at Dashbird. So I think this is a good article. The no customized events, I'm now definitely remembering. It's like 8 o'clock now, so forgive me. But yeah, so I mean, passing it a hard-coded payload, you can make it somewhat dynamic if you're using some type of infrastructure as code, like a serverless framework, but it's still going to be hard-coded to some degree. Only supports recurrent schedules. Obviously, that's a limitation. And if you need to do something that's every 5 minutes or every hour, this is a really good use case. For S3, if you're storing something like images, you need to actually track when things are being deleted like that. That's a good solution, especially for videos, images, all that stuff. When it comes to DynamoDB tables, this is like we usually think about it as like a sidecar type functionality when we're building applications. If we're writing Node.js code with Lambda and we're doing different operations like that, what we'll have that DynamoDB table with the TTL attribute there, and we'll use that as a way to expire events and trigger some type of process. So maybe you're subscribed for 5 days or something, and then there's some event that needs to trigger off and send an email. DynamoDB is really useful for that. Awesome. Okay, and so it looks like, yeah, that wraps up this article. So let's jump to the next one. I'll close this down. So here we got serverless commit message validation. by Harish. And we're going to be going through this, so I'll pause it here and we'll come back and take a look. All right, so I skimmed through the article. This one is about setting up some commit validation with Jira. So the idea here is that it looks like they're using ServiceNow, and they want to confirm that the commit has a Jira issue number into it. And if it doesn't, then it wants to fail the commit or fail the build. Yeah. So so this blog covers steps to build your own serverless commit message validation, which you can take actions faster in your DevOps pipeline. Some prerequisites here: AWS account, code commit, Lambda, SNS, IAM roles, basic Python with regular expressions. I do want to zoom in on the architecture here. So what the user does is commits to code commit. The commit then invokes a Lambda function. The Lambda function evaluates the message and sends a notification SNS. SNS then triggers an email back to the user. And then the Lambda function, after successful validation, will then trigger the DevOps pipeline. And so what you're doing here is you're setting up this kind of safeguard in the Lambda function, which is going to prevent the pipeline from even deploying if some properties aren't met here in the Lambda function. So I think this is a really cool use case. They're using it specifically for Jira, checking the Jira, the Jira ID, but you could use it for a whole bunch of other things, based on your context. So in this article, I'm not going to go through it in a whole bunch of detail because he does detail out all the steps. So first, they create a code commit repository, and then they go through, and I believe they're setting up the initial repository here. And then they're going to need to set up the IAM role, which is going to allow to give access about what can be executed in it. And so you can see that here: AWS code commit read only, Amazon SNS full access, and creating the full role. And they're going to create an SNS topic and subscription with email. So they'll create a topic, and then they'll create a subscription, and then they'll add in the email that it's going to be subscribed to. And then finally, they're creating a Lambda function here with Python 3.7, and they're going to check in the role that they created before with the commit check role. So you can see that in this screenshot here. They have it set as Node.js 10, but they'll probably switch that to Python. And then the existing role is commit check role. It looks like the code that needs to be added in the Lambda console is listed here. So this would be an interesting project to turn into a full serverless framework project where all the automation, including the repository, the IAM role, the code commit setup, and the Lambda function, all that's wrapped into a deployable pattern. Because at the moment, obviously, you would have to step through each one of these steps. So if anybody's watching this and has an interest in doing that, that'd be something that'd probably be pretty useful. And then scrolling down, we can see that the notification or the topic is up, and that's what we're looking at currently. We have the code, which is ready. You can see here that we need to add a trigger, so he's going to hit add trigger and then select code commit. He adds the code commit there and adds the repo of repo check, and the trigger name is called repo check trigger. And he's putting all repository events there, so anything that happens with the repository with code commit is going to trigger this Lambda function. And then you can see that here, code commit is going to trigger the commit check Lambda function, and then it's going to validate the commit message. And so now it's ready to be tested. So he's going to edit the file here to trigger it, and then he's going to hit commit message or commit changes, excuse me. And that's pretty much it. And it says that because this commit message here. Commit for new sprint task, because this doesn't have the Jira number in it, it's going to fail. Whereas if it had Jira 1101, then it would be a success. And so that's a very simple way to set up a basically commit validation with code commit and Lambda and Amazon SNS. So great article, feeling it. All right, so this one, the 5 serverless framework commands that you should be using. I wrote this one. That's funny. By Ryan Jones. That's me. Woo! So I'll still read through this. Let me pause real quick. All right, cool. So I was just ordering some pizza. I'm back. Or I already ordered it. I didn't just order it in like 30 seconds. Yeah, anyways. Okay, so back to this article, the 5 serverless framework commands that you should be using. So yeah, let's jump into it. So the first command here is packaging. So for packaging, why this is important is that when you build serverless applications with the serverless framework, you want to package up your applications and see that locally, right? So people talk about the limitations on Lambda and how big your package size could be, or cold starts. A really easy way that you can evaluate if you have too many dependencies, or if this binary file is going to be too large, or if you're making some changes and you just want to see, okay, I'm going to package these 4 Lambda functions individually, and I want to validate that they're actually packaged individually and they have all the proper things they need. Because otherwise, if you have a slow internet connection and you're packaging 4 individual functions and they're all like 50 megabytes or something, that could take 5 minutes, and then you're not even going to be able to see it because it's now been uploaded by the serverless framework to AWS. And to then get that zip file, you can always look inside the .serverless file locally. However, the other way that you can validate is by going to the S3 bucket where it actually got uploaded, downloading the zip file, which is going to be 4 times 50 megabytes, 200 megabytes, and then you're going to then have to open it up and then look at it. And the easiest way to do this without any complication is once you get it kind of your initial infrastructure set up with the serverless framework and your serverless.yaml that's going to have your Lambda functions and all your AWS resources, just run SLS package, and it's going to create a .serverless folder locally. It's not going to deploy any code. You don't have to worry about updating anything. And then you just open that up and then open the zip file and then inspect it and just make sure that all the individual zip files have the proper things. If you're doing any complex packaging, this is very important because you want to make sure that if you're doing like include and exclude patterns, that you actually have all the proper files. For local testing here, you can do SLS invoke local with a -f, and you can pass it a function name, and then you can do -d, and that's going to be for data. So you can see here that we're passing a stringify JSON object. Then we have the -b at the end for verbose, which is going to give us a little bit extra information from the serverless framework. I like doing this command a lot because it allows me to test my code locally. And so what happens is that when you make the serverless.yaml file, you can then have a section that has, like, let's say, hello, and then colon, and then the handler and all that stuff. And so you can say SLS invoke local -f for function, and then the function name is hello, and then you can easily pass it a stringified JSON object. There's also another way that you can do this, and I mentioned this down here. You can run SLS invoke local -f, and then you can give it your file name, and you can pass -p here, and P stands for path. And so, you may find it pretty tedious to create a JSON object and then stringify it just to pass it through a terminal, especially if your JSON is massive, right? Well, in this case, you can actually pass a JSON file itself that you stored locally. So you can see here that we have a path of test events. So this is a directory that's locally in our project. And then we have one called create user.json. And so you can imagine that as you're testing, and you're not like over investing into unit testing at this point, you're just kind of like sampling if your stuff's going to work or not, then you can do this approach, and it's actually going to test the Lambda function. It's going to test the function locally without trying to emulate the Lambda environment or spin up a Docker container or upload it to AWS and then test it. It's a very simple way to just validate that the stuff works. But then if you need to actually bring that any further, there's something called Sls Offline, and that's going to basically emulate like an Express server, and it's going to start up your API. It's going to look at the serverless.yaml. It's going to see that there's all these Lambda functions that are defined, and then it's going to spin it up on localhost, and then you can grab that URL that's defined there, and you can take that over to like Postman or to your Chrome browser, and then you can start actually testing your endpoints. And so I like to use SLS invoke local initially, but then after I get past like the very basic like POC stage, then I'll move to SLS offline. However, if you're already using unit tests and you're very comfortable working with like Jest or like Mocha Chai, I would just recommend going the unit testing route right off the back, because then you just eliminate the entire complexity around serverless and around emulation locally. And so unit testing is probably your go-to path, I would say. So write your code to be easily modular and easily testable, and then you run into less problems around local emulation of like things like SQS and SNS and all these things because you can just mock it. Okay. So then moving to deploying a single function, we have the SLS deploy function command here. Once again, we can pass the function name of like hello, and what that's going to do is it's going to deploy just our individual function. So imagine that example that we had where we're basically saying package up 4 individual lambdas, and then they're all like 50 megabytes, and so that's going to be very slow. But we can do SLS deploy function, and then we can give the function name. So let's imagine those 4 functions. We have function A, function B, function C, and function D. Well, let's say we only changed function A, so then we can say SLS deploy function A, and then we only changed function D, and we could say SLS deploy function -f function D. And now all that's going to deploy independently, and we're not going to have to wait on 4 uploads, just 1 upload. And so it's going to be a lot faster development at that point. So install plugins like a serverless master, well said. So you can install a plugin by doing npm install --save dev, and you can find a whole list of plugins. If you search serverless framework plugins inside of Google, you'll find those. And then what you'll do inside your serverless.yaml is you'll add a plugin section. And there's also another way that you can do this. You can run SLS plugin install --name and the actual plugin name. And what that's going to do, it's going to install the package into your node modules, and it's also going to add it automatically to your serverless.yaml. So this command is really nice. It's one single command, whereas this command up here requires both running npm install --save dev and manually adding the plugin section to your serverless.yaml. So if you're feeling lazy, you can use this command, and that's going to save a little bit of time. When it comes to installing a specific version, you can add the @version at the end. So it's the same as before. However, you can install @1.2.0 of the Sls Offline plugin, for instance. So great things are done by a series of small things brought together. Vincent Van Gogh. That's cool. I didn't even know. I must have forgot that I put that there. Debugging serverless framework variables. So if you want to figure out what your stuff is actually doing, you can run SLS print. So down here we've got the service, the provider, and the custom sections, and you can see there's like some. If you're not familiar with the serverless framework, then this may be a little bit confusing. But I'll walk through this one line. So what we're saying is option stage, and what that basically means is that we can pass --stage into the CLI command. So where we run like SLS print here, just imagine there was a --stage, and then we put something like test. So what will happen is that this value inside our serverless.yaml will swap out for test. And if you're curious about all this stuff, we actually have a training course where it's completely free. We've posted it on training.serverlessguru.com, and it's also on YouTube. You search for Serverless Guru, and you'll be able to find 0 to Paid Professional is the name of the course. And I go through all this stuff about serverless framework, all these commands, and we build an API and do all that stuff, and it's 100% free. So definitely jump on that. Moving down, after we run this SLS print command, you can see that this file, which has all this $ curly brace, we run SLS print, it turns this file into this file. And so now you can see that, like, okay, for instance, service now says real-time weather. Well, this service here, this $self : service, that comes from this value up here. And so you can kind of work backwards and figure out how things are connected together by using this SLS print command. And especially, let's say that you missed a T on this, right? Well, if you missed a T, or let's say you had like a missing quote or something, right? You can test it here before you have to worry about the deployments. And a lot of times what you'll do is when you're working with serverless and you're working with the serverless framework, you'll make these deployments thinking that it's going to work, and then it doesn't, and then you're confused, and you think it's something to do with maybe your code, when actually it's a serverless.yaml file that's slightly off a little bit, and it's hard to trace down where all these problems are happening. So the way that I like to think about it is build out your serverless.yaml first, run SLS print, that confirms that your entire file works, then run SLS package, that confirms that the packaging works, then run SLS invoke local, That then confirms that the Lambda functions work, and then finally deploy it with SLS deploy. Some few other things down here. What Serverless Guru does. If y'all aren't aware, you can check out our website at serverlessguru.com. We have a team full of serverless experts that help with consulting around like serverless migrations, moving existing systems in. We're a full end-to-end serverless consulting company. We're one of the most, not like most notable, but we definitely made a lot of content around serverless over the past year, and we're continuing to do so and working with bigger clients and just trying to make the vision around making a big impact and then giving that back to the community. And that's what this video is. That's what the templates are. That's what these articles are. That's what the training course is. It's all focused around, making a big impact and then sharing that back so that everyone else can feel empowered and keep going with that. And you can even see there's an article called Serverless Impact. So enough about that. And you can see my information down there. Cool. Nice job on that article. All right, so this article is going to be on how to generate deployment artifacts in your CI/CD pipeline for serverless apps. So with that, I'm going to pause the video. I'm going to read through this article. That looks like Frank's image. Yeah, let's see. Oh, Jack. Okay, all right. So I'm going to pause it here, and then I'll start it back up, and then we can talk about what's in here. Cool. All right, so this is going to be a quick one because the topic of this article is the same as what we just talked about, actually. So what's going to be talked about here is how serverless deploy works, and so we talked about that a second ago. When you run the serverless deploy command, it's going to first run serverless package, and that's going to create a .serverless folder locally. And then you can go inside that .serverless folder, and you'll see a zip file, and you can actually open the zip file, and you'll be able to see exactly what files are in there. So your CloudFormation template file, your Lambda function code, as well as a serverless state.json file. Then it's going to upload that file to S3. It's going to update your CloudFormation template with S3 pass for the Lambda zip files, and it's going to submit the template to CloudFormation to kickstart the deployment. And so to look at that in a little bit more detail, for a CI/CD pipeline, we want to separate this two-step process. To this, we can first do the packaging step. So you can run serverless package, and then you can run serverless deploy. And so with the packaging directory, that will then create a separate folder, it looks like. Let me double check. Yeah, so with this -- package, this is a path that you can give, so you can actually tell it a specific place to put it. And then for the serverless deploy command, we can then pull it from that package directory and then make the deployment from there. If you're interested in reading more about this, the seed team is really good about doing things like here, like serverless tips. They also have the serverless -stack, and that serverless -stack is actually a super useful tutorial about doing all types of serverless framework usage. And I personally have given it to my team before, and they've used it, and I've given it to clients, and they love it. So definitely check out c.com or c.run, excuse me, as well as serverless-stack.com. Okay, in this article, differences between put and post for S3 signed URLs. So let's kind of scroll through here. So this is the 9th post in the series. So if you're ever interested in doing AWS signed URLs, then this is the place to go to. And I guess what I would say here is, I'm not going to go to the first one. I'm not going to go to the first one and then work down. But what I'll say is that for signed URLs, these are used for situations where, let's say you have some S3 image. Okay, so let's say that you have some S3 image, and you don't want these to be shown publicly. And so what you can do is you can create what's called a pre-signed URL, and that's going to allow you to keep the S3 bucket private, and then you can generate these S3 URLs based on the user signing in, and you can give them direct access to a specific path in an S3 bucket, which has temporary access, which you can set to like 60 seconds. And so for 1 minute, if they have that URL, they can access it. Past that point, they can't. And so this is a like 9 or 10 different articles about how to set this up and what it means and all those things. This specific article is a 6-minute article about the difference between put and post S3 signed URLs. So I'm going to scan through it real quick, see if there's any things that we can pull out of it. But if you're interested, definitely check out advancedweb.hu and then follow this whole tutorial, because I think that that's going to probably be way more impactful. All right, so I read through it very briefly. There's a whole bunch of different structure in here. I'm going to jump all the way down to the bottom, and the verdict is if both are for the same purpose, which one to use? And it says use post URLs. While put URLs are simpler to use, they lack some of the features of post URLs. And since constructing a form and submitting from JavaScript is just a few lines of code, it shouldn't be a problem. So I would probably go with what the recommendation here is, use post URLs. If you want more information about the different minor differences here, definitely check this out. Also, I like that he adds in this shameless plug here. I think that that's well done for a call to action button, so kudos on that. Sweet. All right, so now we're over to Lamigo. And this one is getting the most out of CloudWatch logs by Mr. Yan Kui here. Excuse me. Excuse me. And so this is going to be about understanding CloudWatch logs, going through it, and yeah, let's kind of just scan through it real quick. So I'll pause it, and then we can pick it back up. All right, so I'm going to do my best to move through this. So this post is by Yan Kui, and he's one of the serverless heroes that we have out in the community. This article for Lamigo is going to talk about the different functionality of CloudWatch. So right here we have the CloudWatch log section. What is basically being talked about is that every function is going to have a /AWS/Lambda prefix. So you can see that inside of these log groups here. And so we'd actually go to the CloudWatch console and you're trying to find the Lambda logs. It'll have /AWS/Lambda. Then you can click on this log group. And then when you click on it, it's going to have a series of timestamps here. These are the different events that came together. And these log groups can actually group together. What I've noticed is that it's based on the container. So if a Lambda function is running and it's reusing the same container, it'll reuse the same log group. But then if that Lambda function stops, it'll then create a new log group, as well as if there's concurrent events taking place and they're creating additional containers, those will have separate log groups. And then finally, if you push new code, then they'll create a new log group. So that's what I've noticed. And so I think he's kind of mentioning that as well, as like each concurrent execution would write its own log stream in parallel. And then he also mentions that you can also move logs from ECS to CloudWatch logs really easily, and there's an API for doing that that's built in. For services such as Kinesis Firehose, it's also built in support for sending service logs to CloudWatch as well. In terms of pricing, the pricing for CloudWatch is 50 gigabytes for data ingestion, and then 3 cents per gigabyte for storage. So total, it's 53 per gigabyte. I think what's interesting there is that for a message that we looked at before, something that was, I think it was like 4,000 bytes was the log size. Was just one single log was like 4,000 bytes, and then that 4,000 bytes over like 1 billion invocations ended up costing like $2,000 a month, something like that. So it can actually get pretty expensive, because when you're talking about 1 billion invocations of a Lambda function, you think it's going to be that really cheap cost when you think about the cost of running these Lambda functions. I think it's. Give me 1 second. Okay, I'm back. So I just wanted to confirm the Lambda free tier has 1 million per month that you get, and that costs like 20 cents every additional 1 million. And what's interesting there is that for 1 billion invocations, or 1 billion invocations, the price that I was coming back with was around like $200 for the Lambda cost. But then the actual CloudWatch log cost could be exponentially more. It could actually be as high as, just for that one log, repeating every single invocation could cost $2,000. If you had a whole series of logs, 10 logs, that could easily get out of hand pretty quick when you're working at that scale. And so some of the other things that. Okay, all right, so we're back, and the thing down here is he's talking about CloudWatch logs is significantly cheaper than most of its competitors. The system also auto-scales based on traffic, is highly resilient, and can store data for practically as long as we want. So what's the catch? Limitations down here, you can't query across multiple log groups. So up here, we're looking at all these different log groups that are getting formed, and then we can't actually search it, right? So let's say that, let's say that we want to search across all of these different individual log groups, and we want to say, excuse me, I was looking at the log stream screen, I think. Yeah, these are the log streams, log groups right here. So let's say you want to search across all of your functions for something. You can't actually do that. He mentions that CloudWatch Logs Insights, which is down below, addresses this limitation by letting you query multiple log groups at the same time. However, most people forward their logs from CloudWatch Logs to a managed elk stack, and to do that, we need to use a subscription filter. Also check out their ebook, The Complete Serverless Monitoring Guide by Lamigo. So subscription filters here, it lets you stream log events to a destination within AWS, and so you can set it to Kinesis Streams or Kinesis Firehose delivery system or a Lambda function. I'm going to kind of scroll through this a bit. Definitely come back and read this in more detail if y'all are looking for some really big breakdown on the CloudWatch Logs front. Jan Kui does a really good job on this. He says, fortunately, whichever destination we choose, we have open sourced some tools to make it easy to apply them to all our Lambda logs. So that's a big one that I want to point out, is that Lamigo has done a lot of stuff for the open source community. And so they have this one here. Let's go ahead and open. And in this, you can actually set up looks like their stuff, to then forward these logs to other AWS Lambda apps to automate chores around AWS or around CloudWatch Logs. Yeah. Cool. All right, moving down to metric filters. This is one of the most underappreciated features of CloudWatch Logs, is the ability to turn logs into metrics and alerts with metric filters. So right here we have the one Lambda log group here called Hello World. And then as we scroll down, what he's doing is he's loading a pattern in. He's selecting log data to test, and then he's actually seeing the output there, which is like one result. And then you can assign a metric to it. So after targeting the right log messages, we need to turn those into metrics. On the following screen, we can configure that conversion. So filter name is loading index.html. The filter pattern is loading index.html. The metric namespace is big mouth. The metric name is loading HTML. Metric value 1, and then you can create the filter. If we use metric value 1, then the metric is essentially a count of the number of matched log messages. This is all we need for many use cases, such as counting the number of errors. But if we want to collect custom latency metrics, then you can get a little bit more complex. So you can see here, date time 20 star, and then it fills a couple more fields here: request ID, metric name, latency, and unit. And then it's the select log data to test. And you can see that it comes back here with the date time, latency, metric name, request ID, and unit. And I believe that that's what he passed up here in the filter pattern. So you can see that this comes back here. To capture the latency values, we need to apply a pattern that captures different parts of the log message. The following example, for instance, captures the latency value and unit in named variables. And so you can see that here, so milliseconds. It says that we can then reference these named variables when we define the metric. So he sets up the filter name of custom-latency, he gives it the filter pattern, and he actually specifies a $ latency for the metric value, as well as date time, latency, request ID, and unit. And then once the metric is created, we can see the custom metric in the CloudWatch metrics console. And so then you can see that here, where we have the metric name of Dynamodb latency, and then you can actually see how that's performing. And so these are being generated by the CloudWatch logs that are coming in, and that's pretty cool. Limitations, while you can parameterize the metric value using name fields, you can't parameterize a metric name. This means you need to create a metric filter for every custom metric you intend to log from the function. As your application evolves, it becomes something that's easy to forget. Also, there's a hard limit on 100 metric filters per log group. So basically, as you're working at scale, you're going to need a much more complex solution for this, but as you're getting started, these are potential outcomes that you can use. All right, next up we have the CloudWatch Logs Insights. So inside of here, we're going to look at a few different things. So you can see that they're using SQL type queries. So they're saying fields, timestamp, and message, sort by timestamp descending, and then give me the last 20, limit the amount of logs coming back to 20, and then filter the message where it says loading index HTML. So what then will happen there is that you can see this being printed out. So it's filtered these back, it's given him back 20 results. It's given him these fields that he asked for, which is timestamp and message. And then he has the messages where they match loading index.html. And so this is a pretty cool thing that you can do here. This was announced in 2018 at reInvent, where you can use SQL-esque queries, and then you can sort through this data here. You can also add this to a dashboard, and from there you can then reference it again. Another thing here is that you can see summaries of most recent invocations and the most expensive invocations. So let's open this up. So here you can see CloudWatch Logs Insights. You can see the the request ID and the duration in milliseconds and the build duration. And so this is giving you an idea for the most expensive. Sorry, that was the recent ones. The most expensive ones are down here in gigabytes a second. And you see here 4,700. Build duration was 0.58 in gigabyte seconds. And then based on that, you can get a quick idea for the different Lambda invocations and which ones are costing the most money. It says if you're logging structured data in JSON, then CloudWatch Logs Insights can even discover the fields in your JSON message. You can reference these fields in your query just as you would do in an Elk stack. So let's take a look at here. So what we're doing here is we're pulling back the fields timestamp and message, and then we're sorting by timestamp descending, limit of 20. And there's a filter here called call-chain-length equal to 1 and count equal to 8. And if we look down here, you can see count is equal to 8 inside of that JSON message that's being logged. And also see call-chain-length is equal to 1. Oh, I think my pizza's here. So yeah, so that is kind of interesting that you can actually go into the log here and you can actually specify count is equal to 8. And that's really nice because it allows you to basically filter the JSON that's being passed through from your Lambda function. And CloudWatch is able to do that without any other tooling, which is something that Jan is pointing out here. All right, and I'll be right back. All right, so I continue real quick and then I'll cut off because I've got my pizza. So limitations on CloudWatch here. There's no option to select all log groups at once. I assume it's to avoid creating costs for the AWS customers. That said, it can still be very useful understanding the behavior of a single function once you have somehow pinpointed which function to investigate. The summary down here, subscription filters for streaming log events to a destination in real time. Metric filter for creating CloudWatch metrics from log events. CloudWatch log insights for analyzing log messages using ad hoc queries, which is kind of cool. This one's a new one from 2018. And yeah, so he basically says that you should consider adopting good logging practices which are not specific to CloudWatch. One of the easiest and most effective things you can do to make your logs more useful is write structured logs. And they have a link here to that, which is on burningmonk.com. And you need to use structured logging with AWS Lambda. It says many people spend more on CloudWatch logs in production than they do on Lambda invocations. And we talked about that a minute ago when we talked about how much the invocation cost would cost for 1 billion invocations, which is roughly like $200, versus how much the logs would cost, which would be 10 times that, probably at like a minimum. So to keep the cost of logging in check, you should not be logging at debug level in production. So there's different ways that you can handle that. You can actually, I'm pretty sure that Jan probably has an article on that, so definitely just search that into Google. But you can also get really creative with how you do it, and you can make sure that the logging that you're doing, if it has an environment variable of dev or something, then don't log. Or sorry, if it has an environment variable prod, then don't actually log those out in production. That's a very easy way to do it. To make these good practices easy, he built an open sourced the Dazen Lambda power tools while at Dazen. and its logger and middleware supports structured logging, correlation IDs, and sample debug log outputs out of the box. So definitely check this out, Ws Lambda Power Tools. And with that, that's the end of the article. Check out some stuff from Lamigo. They write a lot of good articles, and Yan Kui is always putting out good content. So yeah, I'm going to close this one down. We'll read this next quick title real quick. An easy way to manage serverless project resources by using AWS resource groups. So this is a quick one, but I'm going to come back to it in the next episode of this. This was episode 3, I believe. And the goal is just basically getting through all the articles in issue number 50 and then evaluating if this is a worthwhile pursuit or if I should do it in a different manner. So I hope you got some value out of this. This was Ryan Jones from Serverless Guru. Thanks for watching, and I'll see you on the next one.